Hi, this is John Baichtal, and you're watching Arduino for Beginners, a series of tutorials that teaches the basics of the Arduino microcontroller and how to create hardware and software projects around it. This series is based off my book, Arduino for Beginners, Essential Skills Every Maker Needs. It's packed full of Arduino projects and maker techniques and features chapters on programming, sensors, tools, and motors. You can learn more about me and my books at my website, nerds.net. This is the Arduino Uno. It comes in two different varieties. You have this one has the main microprocessor chip embedded into the board, whereas this one it's removable. And a lot of people might look at these and wonder, what is the difference between them? Which should I buy? Well, here's the deal. The only reason why there's two different versions is that the Arduino project, which was manufacturing these, ended up running low on these big ATmega chips. And I'm going to go into more detail about what those chips are all about, but for the time being, suffice to say that this chip and that chip are pretty much the same thing. They just had to go use the surface mount chips at one point because they ran out of these ones, but ultimately they behave the same way. The main difference for you guys is that if you were to fry this chip, this board is done. But if you were to fry this chip by accident, you could replace it and not have to buy a new Arduino. Okay, so let's forget about the surface mount Uno and focus on this one. This is like the standard Uno. If you buy an Uno, it's gonna probably look like this. So, what exactly do all these things do? Well, let's start in the lower right-hand corner. These are the analog pins. Now, what is the difference between digital and analog? Well, analog refers to something that can return a whole range of values. For instance, if you turn on or you attach a light sensor to your Arduino, it's not going to just say, oh yeah, there's light. It's going to say there's light and this is the level, and it's going to range from, for example, 0 to 1027. Next, let's talk about the digital pins. These are the ones up here, and there's actually some complicated permutations, but I'll go into those in a future tutorial. We're just going to cover the basics here. So what would you use the digital pins for? Well, they're for connecting such sensors as this accelerometer, which always knows what direction it's going and how fast. It has a little microchip on the bottom of it, and you plug it into a digital pin, and if you have it set up right, it will send data to the microcontroller telling it where it is and how fast it's going. And it does it by sending a string of numbers to a digital pin. By contrast, like a button or switch also uses the digital pins, but it simply returns a 1 or a 0 depending on whether the switch is pulled or not. Next, let's cover the power pins. These are the ones that are right here, and they take the power from the USB or the wall wart, and they convert it into a format that most Arduino projects can use. There's a 3.3 volt and a 5 volt pin here, and you want to use those to power your projects. And there's also a voltage in pin, and that one's kind of intriguing because you can wire in power directly to the board without using either of these, and that gives you a few more options for how to power your board beyond the standard 2 ports. Alright, and then I just want to briefly cover what these are. This is the voltage regulator, this chip here, that takes the DC power from the wall wart and converts it into the voltages that we use for Arduino projects. And then these are capacitors that help with that. Alright. Next, let's talk about the reset button. This is it right here, and it doesn't turn off the power to the Arduino. What it does is it takes the program that's already on there, and it could be running in a loop and freezing up the Arduino, for instance. And it basically resets that program so it starts from the very beginning. So if you ever run into any difficulties with your program or the Arduino doesn't seem to be responding, definitely hit the reset button. And then there's some LEDs here. You can see them right here. The one with an L on it is basically the same as pin 13. So if you have an LED flashing in pin 13, it's also going to be flashing in this little LED here next to the L. And then there's a power LED here. If you plug in the Arduino, here I'll just do it just to show you. This LED lights up. And then the LEDs marked TX and RX, those govern the transfer of data. And if you're sending data to your Arduino, those will flash. And so if you're uploading something and it doesn't seem to be working, keep an eye on those TX and RX LEDs, and that will help you determine whether data is being transmitted. The last thing I want to talk about are the specs of this chip, as well as this one right here. This one right here, it's a ATmega 8U2 digital to serial converter. It basically takes the data from the USB and converts it to a format that the Arduino can use, which is serial data. Serial data is basically when one bit of information is sent at a time. So it's relatively slow, but also rather simple and easy to manage for people who are beginners. And then this chip is the ATmega 328P. That's the main brains of the board, and it has 32 kilobytes of data storage, 2 kilobytes of RAM, and 1 kilobyte of non-volatile memory. That may not seem like a whole lot, but Arduino programs are super small, and it'll be just fine. In the next tutorial, I'll show you how to download, install, and use Arduino software interface. It's called the Integrated Development Environment, or IDE. You'll learn how to navigate the IDE and access its very considerable resources.